All right. Good afternoon, class.
Good afternoon, ma.
I welcome you to the class AEM722 Ruminant Animals. This is our first virtual class. I noticed that you have all interacted through the virtual learning environment, and I hope you have seen your timetable for the week, and you know that we are having this virtual class, and we will also be having some assignments like we had the other week. I will be uploading the video to this class immediately after we finish. I will upload the video so that you can go through it. But I just want us to discuss briefly on what we are having for the second week of this class. If you notice from the topic we sent, we are talking about digestion in ruminants. That is what we have for this week. I have uploaded the PDF lecture notes, lesson notes, and I hope you will take your time to really study it. I have the PowerPoint I have also made available to you, and the video will soon be up. But I just want us to go through the slides that we have for the class so that we will be able to have a better understanding when we look at the video. So I'll try to share my screen so that you can look at what we have. I'll go through it as fast as possible so that I don't take too much of your time and you'll be able to do the rest yourself. By now, you are familiar with the look of these animals, and so I keep leaving them here so that you will be able to remember examples of class of ruminants that are there for you to see. But for this class of today, we are going to talk about the digestion process in ruminants. We'll talk about the various functions of the ruminant stomach. We'll talk about the end products of microbial digestion and how they are absorbed. And we look at the anatomical difference between the adult ruminant and the mature animal. It's quite interesting to note that when a ruminant is born, the digestive system and process is very different from when it matures and becomes an adult. This is very different from what happens in the non-ruminants, such as man. And I think, shown you this diagram in the previous video. And once again, I'm repeating it here because that is the crux of the matter. As far as the ruminant animals are concerned, the major issue is actually the digestive system, both in terms of anatomy and in terms of the process that is involved. So I want you to take note of this. What you can see here, you are seeing a reticulum that once the food enters the mouth, it gets into the reticulum. But there is no distinct difference between this reticulum and the rumen. And sometimes this whole area is referred to as the reticulorumen. You see a small area here that is referred to as the abomasum. This area serves as a sieve. When feed enters, it absorbs a lot of liquid material. And when you are getting to this component of the stomach that is referred to as the abomasum, that is actually the same as the true stomach in the non-ruminants, such as the dog, such as the cats, such as pigs. I think they are very good examples, and such as the chicken. And so I want us to know that in the digestive process, this stomach, this reticulorumen that I've talked about, is actually made up of huge pillars of muscles. And so when the animal eats forages, they reside in this stomach or rumen, and the pillars help in churning the food material. It acts like a vat. that as it squeezes and unsqueezes, the feed material becomes mixed up. That is what happens in the stomach of the ruminant. And so this squeezing and unsqueezing actually brings about having two layers in the stomach system or in the rumen. Let me use the word in the rumen. So there is a top layer of solid and there is a bottom layer of liquid. That top layer of solid forages or forage material that has been consumed is actually what the animal regurgitates back to the mouth when it is resting. So I'm sure you have noticed in your environment, you see a cow just sitting down and eating and eating and eating. What it is actually eating is this top layer of solid material. It returns it to the mouth, chew it, swallow it, return it. So it helps in reducing the particle size. Not only that, in reducing particle size, it creates a greater surface area for microbial digestion. That is the mechanism behind this chewing and rechewing of materials and what you see in animals when they regurgitate their feed materials. And so, you know, when an animal eats this forage, there are different components to a feed material. There is the carbohydrate, there is the protein, and so on and so forth. So in terms of carbohydrate ingestion, what actually happens in the rumen? That is what we are trying to talk about. What is the digestion process of the carbohydrate in the rumen? And so when you look at the diagram we have here, I'm sure you will make some sense of it. The arrows are there for you to see. I'm not in this class to give you a word-for-word lecture, but just to stimulate your interest so that we can discuss what you have read, where you have issues that you need more clarification, or where you have a contribution that you think you can make to the class, so that we can talk about it. That's actually the essence of facilitation. It is not to really give you a class lecture per se, but I want you to study this diagram. You will see that it starts from the mouth. It gets to the rumen. Then back to the mouth, we talked about regurgitation. That's what happens. Then back to the rumen. The digestion takes place here. In the rumen, this is an oxygen-free environment. So it is only only microorganisms that are anaerobic that can actually reside in the rumen because there's no oxygen there. And these microorganisms in the rumen attack or are able to attack the beta linkage in forages. Ruminant animals, you and I, and pigs, do not have these microorganisms, and therefore most of the forages we consume, we void them out intact. But for the ruminant, the presence of this microorganism here actually allows the digestion of this thing. Why are you all not in video? Hello? I think you all need to be in video because they will assess the your presence in the class. So try to put your video on so that you can see. Like where Marafa is enjoying in his house and eating his correct food. Abdul Gafar, welcome. So that's really what happens. And so when it gets that, the food goes to the reticulum. And there's filtration, like we said, there's some form of absorption of liquid material, and then it gets to the omasum and to the abomasum, and then it goes to the duodenum, and small and large intestine, and so forth, so on and so forth, as you know. Now, I want to talk about the end product of fiber digestion in ruminants. You know, in the digestion in non-ruminants like us, we say the end product is carbon dioxide and water. There's energy, there's carbon dioxide, and there's water. But in the end product of digestion of microorganisms in the rumen, it leads to the production of volatile fatty acids, VFA. That is the end product. These volatile fatty acids are absorbed through the rumen wall. So this gives us a second function of the rumen. It is not only a fermentation vat, but it is also an absorption area where nutrients that are digested are being absorbed. And this end product of carbohydrate digestion in ruminants are the volatile fatty acids. In terms of energy utilization, the VFAs give less energy than the total digestion in monogastric animals. If a feed is broken down completely to carbon dioxide and water, it yields a larger amount of energy. VFAs are like intermediary substances. They do not give as much energy, but then they enable the utilization of materials that would otherwise have been wasted if they were consumed by monogastric animals like us. And this takes me to another aspect of the digestion process. And I want us to look at the diagram that you have in the second aspect. You can see that we said microbes in the rumen help digest the cellulose, such as products that are fatty acids, and they also act as pods that help in regurgitation and rechewing of food, and water is absorbed in the omasum and digestive enzymes in the abomasum. Now that is the one that we intend to look at very closely in ruminants. Now you talk about carbohydrate. What happens in protein? It's interesting for you to note that ruminant animals can utilize urea, they can utilize ammonia to produce protein. So in terms of ruminant management, you don't only need to feed carbohydrates, maybe like soya beans, maybe like cottonseed cake. You will do that, and those are called full protein. But there are other sources of protein that these animals can eat. And so sometimes you see that you can wet your forage and then you get a little amount of urea, the urea grade fertilizer, soak it in water and sprinkle it on the forage, and the animals will eat it. Now I want you to be careful. Don't go putting urea onto your animal feed, because if the quantity is too much, it could lead to urea toxicity and the animal will die. But it is just to tell you that there are two forms of protein that ruminant animals can utilize. You can see from here that you have the non-protein nitrogens, otherwise called NPN. You also have the two proteins, those are the ones that are in feed. The two proteins now, in ruminant nutrition, when you are feeding non-protein nitrogen, you are feeding very low class of nutrients. But the advantage is that the ruminant animals can improve on this very low quality urea you are giving and turn it into bacterial protein. And then when you decide to feed something like soybean, the ruminant animal, once it gets to the rumen, the microbes will still digest this material and turn it into microbial protein. So there is a leveling effect in the ruminant nutrition. And so you are encouraged to use low class nutrients so as to be able to actually improve their quality as a result of the presence of who is in the class and is making her hair. You cannot make your hair in a class. You stop that. When you finish the class, then you do that. Right. So that is what takes place in the rumen. So we have rumen degraded protein that passes through the rumen and is degraded, and you have rumen undegraded proteins. Now the rumen undegraded proteins, sometimes it is advisable to even coat them so that they bypass the rumen without being digested and get to the stomach. That will enable the animal to make a very good use of it. And when you do that, they are referred to as rumen bypass proteins. These are some of the terms that you continue to see as you go through the class of ruminant animals. I will leave you with this table so that you can actually study the difference between the functions of the omasum and that of the abomasum, and you will be able to also look at further readings that will help you to do that. But it's important for us to note that once the digester enters the abomasum, it is subjected to a series of changes through the actions of enzymes that is similar to what happens in the normal stomach. So aside from the digestion we have talked about for microorganisms, the normal digestion still takes place at the abomasum end of the monogastric animal. And the interesting aspect that I want us to talk about is actually the system of digestion in the young ruminant vis-a-vis that of the adult ruminant. I want us to note that at birth, the stomach of the young ruminant is exactly like that of the non-ruminant. That is to say that the abomasum is the larger portion of the stomach, and that all digestion takes place as a result of enzymic activity. But as the animal begins to grow and begins to eat on a lot more of fibrous materials, what you notice is that there is a change in the system of digestion, and the rumen now begins to enlarge. You can see it in this diagram being small, and what you can see large here is the abomasum. But as the animal begins to grow, you can see the rumen taking up a larger space and the abomasum becoming smaller. At adulthood, the rumen becomes 85% of the volume of the stomach of the ruminant. Now, it's interesting to note that so long as you leave animals on milk alone, the system will not develop in this manner. It is the introduction of fiber and solid feed materials into the digestive system of the ruminant that actually initiates this process of development of the rumen. And so in advanced countries, some husbandry men will choose to raise their animals only on milk. And therefore, this system does not get to mature what you see in this picture. Finally, what are the advantages of this process that we have talked about? I would like us to make reference to this. We have talked about the leveling effect as an advantage. If a feed is of low quality, it can be improved. We have talked about the synthesis of some vitamins as a result of microbial activities in the rumen. Some vitamins can be produced. But there are also some disadvantages in this system. And one of them, like I said, is that the energy production efficiency is low. We said the end product is actually VFA, and therefore the total energy obtained from VFA is low. So as compared to the other classes of animals, it's not as efficient. And we have talked about the decrease in quality. Along on this table are further advantages that are given. The process of ruminant digestion leads to the production of gases. These gases are kind of a waste because they are removed through the irritation process and they are not utilized. A lot of these gases are in the form of methane, in the form of carbon dioxide, and they are wasted. So these are some of them. You could look more on this table to see a lot more of the advantages and disadvantages that we have added. So what have we learned in this, our lesson number 2 on ruminant animals? We have been able to talk about the nature of the digestion process in the ruminants. We have been able to talk about the digestion that occurs both at the foreguts and that which occurs at the hindguts. We have been able to talk about the end products of this digestion, as well as the differences in the system of digestion between the young ruminants and the adult animals. Finally, we have been able to discuss the advantages and disadvantages of the digestion of this class of animals. This is what we have in lesson 2 of this course. we will be having another class subsequently relating to your discussions, but I would just like us to give a bit of our opinion on what we have learned and probably what you also would like to know more about. And so I will call on Israel Akiyemi to just, in a few words, tell us what you have learned. After that, I will ask Abdul Gafar Bello, and finally, I will ask Estelle Abakar Bello to tell us in a few words what you have learned and what you would like me to address in the next class. So over to you, Israel. Can you unmute yourself, please?
Yes, ma. Good afternoon, ma.
Good afternoon.
And good afternoon, other participants of the lecture. So far, what I've been able to get from the beginning of the class, from 1 to 2, is the importance of rearing ruminant animals. For today, I have learned that ruminant animals, when they are born, have or rather, when the adult ruminant animal is mature, what I've learned is that their digestive system is actually quite different from when they were born, and part of what they have been feeding on to the point of adulthood is what has modified their stomach system. So in other words, the best kind of ruminant animals, even as we rear, that we can have will be based on what they have been feeding on from childhood up to adulthood. I think my only question would be that these their end products, apart from maybe the ones that are used for fertilizer, is there any other one that can be used apart from the animal itself? What I mean is, after the digestion, the absorption of vitamins and nutrients, these energies that we have been talking about as the end product, are they solely used by the animals alone, or can they be extracted and used elsewhere? Thank you, ma'am.
All right. Okay, I'll answer that, Abdul Gafar.
Good afternoon, ma. Good afternoon, everyone.
Yeah, good afternoon.
So today's class, I have learned the difference between ruminant and non-ruminant animal, and the difference between the digestive system of the young and the adult ruminant.
Okay.
And I have learned the different processes or the stages that the adult ruminant system takes when they chew the first food, and the processes that the food takes before it finally digests. Like the ruminant stage, they chew the food stays in one chamber, then they bring it out again and be chewing it again, swallow it, the food will go through another process again till the final digestion. I understand that as well.
Okay. Thank you.
And I have no questions, sir.
Thank you. Abubakar, you are muted.
Thank you, Ma, and good evening, all. Actually, from this class, I was able to deduce the difference between the digestion in smaller and matured ruminant. And also, I was wondering, when I was small, actually, we used to see this ruminant animal, maybe sheep, cows, used to, like, when they lie down, they used to like bring back the food and be eaten. Now I get to know the logic behind it.
Okay.
Yes, before actually I was wondering why these people, this type of animal used to do that, but others are not doing it. Actually, now I get to know the reason and the logic behind it. And for question, actually, I don't have any question.
All right. Hosai Jadon.
Thank you.
Thank you. Do you have anything? We can't hear you. Can you unmute yourself? Okay. While he's attempting, do you have anything?
I actually want to apologize for joining late. I had some technical issues, but I think from what the other participants have said so far, it summarizes what the key things we have to learn from the lecture today. about ruminant animals. So I think I'm okay with what they're asking or what they have said so far. Thank you.
Okay. Marafa, are you there? I can't see you. Hello, Marafa. Are you there? Can you unmute yourself? Okay. You have a lot of noise at your background. We can't hear you. Hello, you are muted. Can you unmute yourself? Okay, I've done that. Can you unmute yourself? He's finding difficulty unmuting himself. So let me just move on. The volatile fatty acids we talked about, they are like intermediary end products in the rumen. And so these intermediary end products are really absorbed by the rumen wall and utilized. That it is to say that if you give bacteria something to digest, that is the form in which it can utilize it. And it digests it to what it can utilize. But because they are within the system of the rumen, the wall of the rumen can actually absorb this material, and the animal uses it to produce energy. It is not like a product you can harvest. So you will not be able to say, okay, let me collect it at this stage. And the volatile fatty acid is a collective name. Mostly they are in the form of acetic acid, propanoic acid, butyric acid, valeric acid. They are in that form. And the interesting thing is the ruminants can take it in, convert it to energy, though, like we said, with less level of efficiency as the enzymic or gastric digestion that takes place in the hind guts. Have I answered your question, Israel? Oh, okay. So they are not products like you can say to harvest and use. They are end product of a system within a system. They are end product of microbial digestion within the rumen, but they can be utilized. But if you give that kind of end product to me or a pig, it will still be useless for it. But it is the ability to do that that makes ruminants quite interesting, that makes them able to eat materials as they go, graze day by day, and you see them looking fine, looking healthy. It is because they have in their system this ability. It is also because within the system, they can synthesize some vitamins, particularly water-soluble vitamins. They can synthesize it because of the same process. And so you are not too worried as to let me calculate the amount of vitamin A, let me calculate the amount of vitamin K to give them, because somehow they have the ability to produce these macro and micronutrients within the animal system. So if we don't have anything, I guess we are at the end of our class for today. Please, I will encourage you to do your assignments. The assignment is already there. The date is Friday, and it is time bound. If you go to your virtual learning environment, you will see when it will be available, and you will see when the assignment closes. Please try to do that assignment. Participate also in the discussion forum. It is also to your advantage to know your colleagues and they respond to some of the interactions that you will be sending. I will also be watching and respond to questions as we raise them in the discussion forum. We are asked to have at least 2 virtual classes between now and Friday. So we have had one today. It's not going to be more than 30 minutes, but I would like your suggestion as to when you want us to set up the next virtual class. Do you want it tomorrow for 30 minutes? And when do you want it, so that I can create the meeting link and send it to you, and we just meet for 30 minutes, and that will be it, while I await your response on your quiz and discussion forum. Hello? I'm not getting any answer. Abdul Gafar. This one that you're scratching your head. When are we doing the next class? 30 minutes.
Yes, ma. Yeah, tomorrow is fine for me.
Tomorrow is fine.
It's fine with me tomorrow.
Time?
Same time.
Same time, 3 o'clock. All right.
Yes.
Okay.
Same time is okay, man.
All right. Okay. So thank you. Until I see you next time, I am your facilitator, Grace Johnson. I wish you a happy day, and see you tomorrow where we start the next class. Bye-bye.
Thank you, ma'am.